Okay, welcome everyone to Office Hours. I'm your host, Claire. That sounds really strange. But yeah, today we've got sort of a testing special on Office Hours. So every so often we try and theme what we're talking about. And today, sort of the theme came together because I saw a really great post from Sterling about testing. Dylan and Josh sort of thinking about testing in a different way. And so all like very different ways of thinking about testing. And I myself have just been doing a little bit of work on testing that we've put into the community sphere. So won't really no more introduction than that needed. So I think from that we'll just jump into Sterling if you want to talk about what you're working on, or introduce yourself, talk about what you're working on. And we'll do questions for that afterwards, and then move to Josh and Dylan, and I'll round out. All sound good?
Great.
Cool.
All right, thanks. Hi, everyone. Sterling Paramore, live from my basement in Portland, Oregon. I currently work as a staff data engineer at Inside Track, which is a company that does like student success coaching. So we have an app that coaches use to track their interactions with students to like figure out or to help them either figure out how to navigate all the complexity of getting into college, or once they get into college, like how to be successful once you get there. So those coaches like generate a lot of data, and I'm responsible for managing a lot of it. So I have some slides prepared. Share my screen. Yeah, so I guess Claire asked me to give an introduction to this topic because I wrote up a discourse posting about this kind of suite or API that I've been working with the last several months that I'm calling dtspec, data transform specification. And since this kind of started with when I discovered dbt, I'm going with the stylized lowercase, acronym there. So briefly, I want to go over like where did this idea even come from? In the early 2000s, I've been doing ETL style work for a long time. In the early 2000s, I used to be a computational chemist, so we would generate a lot of like molecular simulation data and had to do a lot of ETL on it. At the time, it was like a lot of like bash and awk scripts, and then when we had to get really fast code, we would write things up in Fortran. At some point, I got tired of the academic world and moved on to like business data analytics. I started working at a health insurance company here in Portland and was responsible for building out their analytics data warehouse using a software suite known as SAS, which is another like dinosaur of a language. But gained a lot of really great experience learning how to work with large volumes of business data. But then at some point I wanted to start moving over to like more modern software development. So I switched it over to a startup that made software for beverage alcohol cells. And there I started using like Pentaho and Redshift. And if you don't know Pentaho, Kettle is kind of like, it's like this GUI ETL tool that is somewhat similar to an Informatica or Talend. But while I was there, I decided to take on some, learn more a little bit about web application development. So I picked up some Ruby on Rails to write like this little like ETL job manager interface to help us track when jobs were running and when they were failing and all that fun stuff. And one of the things that really blew my mind when I started on this web app project was this whole concept of like testing and test-driven development. And it was really eye-opening to see that the web application side of software development had been had been like automating their the tests that they would run on their code for quite a while up to that point. But we didn't have anything like that for managing data transformation pipelines. And it was really eye-opening because up to that point, I realized how fragile a lot of data transformation pipelines can be. You make one seemingly small change to a SQL script and suddenly like you have no data in your target tables, or you've duplicated the data or something like that. you spend so much time like working on these SQL scripts, and you test all these edge cases, and you get it working fine. It's great. And 6 months later, you come back and make a trivial change, and you break everything. And I was like, how do we like recover that? Or how do we get around that and make our systems a little less fragile? So that was a big eye opener for me. And then now in my current position, when I started at Inside Track, we were the shop was just barely getting out of doing a lot of manual data transformations using Excel spreadsheets, and they got out of that by utilizing Ruby to automate a lot of their processes. And I wanted to start taking this idea of test-driven development to data transformations. So I started. Oops. Try to get out. I started building this like kind of test framework in this language called Gherkin, which looks a little like this. Like it's like this English natural language style way for writing feature tests. And it worked okay for a while. It was a little cumbersome to use, not very extensible. And at the end of the day, Ruby is just not a good language for doing data transformations. It's slow and there's really no community. So we moved over to Python, and then tried to take a lot of these testing principles that I learned from Ruby and Gherkin into Python, kind of got rid of Gherkin and started writing everything in Python. And at the end of that, like we could write data transformation tests where you write Python code and you basically set up, here's my example table input would look like this, and my example table output would look like this. And then, when you have this input, then you're expecting this output. But it's all written in Python. You could do lots of like really cool things in Python to make these tests parameterizable and reusable and all that. And then this summer, or rather like late spring, I finally discovered dbt, and that was another like really, really big eye opener for me, because it solved so many of the problems that we continually struggled with our like homegrown data transformation pipelines. And so it was like a no-brainer to me that I wanted to move a lot of our data warehousing over to dbt, but I didn't want to lose a lot of the testing infrastructure that we had built with these Python tests. So that's kind of what spawned this work with dtspec. And dtspec, it's meant to be kind of an API for specifying and testing out data transformations. So with dtspec, a user writes up a test spec, a testing specification as a YAML document. So no Python needed. You write up a YAML document which describes the expected output of your transformations given some known inputs. And so while the whole thing is written in Python, it's really meant to be kind of language agnostic for writing data transformation tests. Like you don't need to know Python in order to use dtspec, since it's all driven through these YAML documents. And here's an example of a very basic hello world kind of test. So we imagine we've got a really dumb data transformation that just takes a list of students. They have an ID and a name, and it takes that list of students and it just generates a new field called salutations, and it says hello to everybody in that list. Right, so this is the way the spec would look for that kind of a transformation, where you define sources. I have one source, raw students. I have a target table called salutations. I'll go into the terminology a little bit more here, but basically I have this way to generate test records for my raw data. So here I'm generating two test records. And then I define a scenario, which is a collection of cases. And we basically say, okay, at the end of these transformations, what do we expect? How do we expect the table to look at the end of it? And this is how we expect it to look. In a little more detail, kind of the workflow for dtspec is that you start out by writing the specification for defining these test cases. The user writes those, and then you take that YAML document or whatever, and you pass it over to dtspec. And then dtspec takes the YAML document, compiles all of the test cases you've written, and builds out tables that you can use for basically for your test data. And then you take that generated test data and you load it into your data transformation system. So this would be like loading it into Redshift or Snowflake or even like Pandas data frames. Like, doesn't have to be a data warehouse. So you load the source raw data into your data transformation system, then you execute those data transformations, and then you collect the results of those transformations, the actual output of those transformations. And you send that back to dtspec, and dtspec then compares the actual results of your transformations with what the expectations were that you set up in the original YAML. And it will report on any kind of differences or discrepancies, or it'll tell you everything's okay, it all passed, and whatnot. So some of the core concepts of dtspec, we've got sources, which are the inputs to data transformations. These are the same as dbt sources. Those map exactly. Targets are the outputs of your data transformations. So in dbt land, these are the models that we build in dbt. And then we've got factories, which are recipes for generating source data. So we've got different ways that we might like want to generate source data. If you've got like several tables that are related to each other, you want them all to be generated so that the foreign key relationships all match up, and use factories in dtspec to define those. And then after that, we've got test scenarios, and test scenarios are collections of test cases where you either have some common data target you want to test, or you have some common kind of source data, or some common factory or way to generate your source data. The individual cases within a scenario specify the actual test that you want the expected output. And they usually contain like small tweaks of the scenario factory in some way. So, when you have an extra record, or this field is populated or this field isn't populated, you can set up all those kinds of things. And then test cases have expectations, which define how the output of the transformations look. And then lastly, which is probably the hardest thing to explain about dtspec, is we have this concept of identifiers. And identifiers are used to keep track of which records in your source system belong to which cases. And for that, these are used to solve a problem that we had with when we were doing this like pre-DBT work, when everything was Python. We were under this problem with our testing suite where we had to run the SQL over and over again, and we had to load data into our warehouse a lot. And it was very, very time consuming because while these modern data warehouses are really, really fast at running through millions and billions of records, the difference between running 10 records, 100 records, 1,000 records, like it all takes the same time, because there's this minimal amount of overhead that any warehouse is going to have to overcome in order to run any data transformations. And we're really being hit hard by that. And so dtspec was meant to minimize the number of times you have to run your data transformations. And we do this by collecting all of the test cases that you've defined in the spec and generating source data that is basically taking all those test cases and stacking them onto another. So here's an actual table, an actual source table for some of our tests that dtspec generates. So we might have, say, 3 records for case 1, 5 records for case 2. Maybe we don't have any records for case 3 because it's testing, what happens when you don't have any data for a particular situation. And then case 4 and case 5, and it kind of combines them all up into one table. So you load that table once for the whole spec rather than loading it, say, 5 different times. And you run the transformation once rather than running it 5 different times. And that helps to mitigate the problems you have with that overhead of loading data into a data warehouse. So getting back a little bit to the named identifiers, and this is a little bit under the hood of dtspec, but with dtspec, we don't worry about the details here, but imagine we have a want to describe a source data table where you have students, their sessions or terms, and then a bunch of attributes. And in dtspec, we would identify these columns as being we would specify these columns as being identifying columns. And then when you specify that in another section in dtspec, it treats these columns a little differently. It doesn't treat them as literal strings. So the student ID and session ID columns in our database are integers. They're just unique integers generated by the application. But we want to write tests that allow us to support the stacking concept. So we write these things as strings, and then when dtspec sees these and it knows they're identifying columns, it does a transformation. So it sees the string stu1 and it might convert it to the integer 3. It sees fall 19, it might convert it 6, and so on and so forth. So you define the source data this way in dtspec. dtspec will generate source data, and when it generates source data, it translates these strings into unique integers and stacks them up so that every case will have its own kind of set of unique integers. You load that into your warehouse, you run the transformations, you grab it back out of your warehouse, and then when you pass it back to dtspec, it converts those integers that it remembers from when it generated them back into strings to do the comparison. So that's a very quick overview of that. Currently at Inside Track, we've been using this. We've been using dbt since like late October, and then for most of November, I was converting a lot of our Python tests into dtspec, and so we haven't been running this very long, but currently we have about 50 dbt models and 150 test cases, dtspec test cases, and it takes about 5 minutes to run all of our tests on a Redshift warehouse, compared to like 50 minutes in the Python pre-dtspec version. And if we have time, I do have like a live, I can give a little live demo of
yeah, definitely.
An example of
anything that's using Jaffle Shop, I get very excited about. So
okay, cool.
I would love
and you
demo.
Confirm for me that it's Jaffle Shop and not Yaffle Shop. So I wasn't clear on that. Yeah, so I put together a little demo of how this can be used with Jaffle Shop, and the link is in the discourse topic that I posted last week. But I'll just show it here. I'll just show how it runs first. Okay, so I'm going to run I've defined a bunch of dtspec tests for Jaffle Shop, and now I'm running them. So this is running locally in a Postgres database. So up here you see all the familiar dbt run. So before it even starts running dbt, this test code will take the YAML file and pass it into dtspec. It generates the sources, and then it takes that source data and loads it into my local Postgres database. After that, it kicks off dbt, which then runs through all the transformations. After dbt is complete, it then pulls the target data back out of the Postgres database and runs all of my dtspec tests. And now it's showing that they all pass. So for Jaffle Shop, here's the dtspec, the set of dtspec tests I put together. So I've got a skip for this case, I only needed one kind of generic identifier that generates unique integers. We've got 3 different sources for this data transformation system: raw customers, raw orders, raw payments. Every one of them has a basic ID column that is, again, just a unique integer. And they also have like foreign keys. So the raw order table, the raw order source has a column in it called user ID that actually links to the customer ID. And the same with payments, has an order ID that links to the orders. So we mark those as identifying columns so we can describe them later in dtspec. And then for this case, we've got two targets of Jaffa Shop: dim customers and fact orders. So these are the two main models of the system. There are more models. There are more tables that are generated in this DBT project. But at the end of the day, a lot of those are staging and intermediate. We could certainly write tests for them in dtspec, but we really only care about these customer-facing ones. So that's the only tests I've written for. And then I've got a very simple data factory for dtspec that I've called customer with order and payment. And so this is the most canonical basic set of data that will allow these transformations to run. We've got one customer record, gave it an ID and a name, one order, which links the order to the user, and one payment, which links the order to the payment. And then in the first scenario, we're going to talk about building the dim customers model. And this is going to start by using this factory called customer with order and payment. So this is kind of the base factory for this scenario. And then the individual cases within this scenario, I always start with this target has data. When I'm writing these things, this is what I start with so that I can make sure that I've built a good base factory that ties together all the records in the right way. Like if I mistakenly didn't tie the order ID to the ID column of the orders table, then I wouldn't have any data, and my test would base thing that just make sure that the most simple nuts and bolts are working. And I've got another test case which describes populating the number of orders field on dim customers. And as you learn about the transformations in Jaffa Shop, you'll see that this is just basically a count of the records in the orders table grouped by the user ID. So I have 3 records in raw orders, and therefore the output of the number of orders column is 3. The one important thing to point out here is that this is a data factory that applies specifically to this case, populating number of orders, which is kind of a small tweak to the factory that is common, that is shared between all the different cases. But the one that's shared between all the cases only has one raw order record. So in this case, we actually have 3 records for this specific case. So we can make these case-specific adjustments to our source data. And I'm not going to go through all the other ones, but I do want to show what happens when you do something unexpected. So let's say I am a new analyst and I go into this code for Jaffa Shop, and for whatever reason, I think there's an off by 1 error in the number of orders. So I have to add 1. So I do I have to add 1 to number of orders. And for whatever reason, this solves my one specific problem that I was had tunnel vision on, right? So I think that adding 1 to this column is going to work. And I'm not thinking about the tests at all now. So I just go and I naively just say, okay, well, does this work? Does this break anything? And I run through it, and dbt runs, and then dtspec reports that there's a problem. So dtspec started by trying to assert this test case about populating the number of orders, and it turns out it fails. And the reason why it fails is because the actual result had number of orders of 4, but the expected, I was only expecting 3 as written in the dtspec cases, but for this kind of dumb mistake I introduced into the code, the actual output was 4. So this tells me there's something wrong. So, either this is maybe this really is what we need. We really need to have an additional 1. So we would go back to the test case and we'd say, okay, well, actually, this is, or wait, remove 1. So this is actually what we expect. And then we'd run this and we'd find that it all passed. But I mean, this to me is the part that's really cool, is that you can modify your SQL and be fairly confident that you didn't break a lot of stuff that has been tested in the past that you didn't test this time. I think that about does it for the demo I wanted to go over today. So thanks.
Thank you so much. I love that. I think like I am often modeling data where like you're piping data through a series of transformations and you're like, I know it should look like this at the start and at the end. And I think like I'm very interested in solving that problem in a better way than like a weird series of seed files and if statements in Ginger and things like that. So yeah, really cool.
Thanks.
Yeah. Did anyone, we've probably got a couple of minutes for questions if anyone had any questions on this. Okay.
Yeah, if you do, reach out to me on dbt Slack, send me a DM or whatever. Be good.
Yeah,
thanks.
Excellent. Thank you so much. And with that, we'll pass to Dylan and Josh.
Cool. Thank you. So hi, everyone. My name is Dylan Baker. I run a small analytics consultancy. I'm going to be talking a bit today about a tool we've built called Spectacles, which is a continuous integration tool for Looker that Josh Temple and I have built. And I'll let Josh introduce himself.
Hey, I'm Josh Temple. Up until yesterday, I ran data for Milk Bar. I'm actually going to work for Spotify starting next week. But yeah, excited to show you this tool that Dylan and I built for Looker.
So I too use Shop for the demo that we're showing today, mostly to make Claire
I'm going to use it too.
But I'm going to talk a bit about this tool that we built on top of Looker. And I thought, given that like everyone from the community has dbt in common, but not necessarily Looker in common, I thought I'd just like briefly talk about what Looker does, which will provide some context. And the testing does very much relate to like what happens in dbt, but a bit of context of Looker is probably required to understand what's happening. So Looker has a language called LookML, which is basically an abstraction of the structure of your warehouse. So lots of people will model out data in dbt and then really just use Looker to define what the like structure of those models are, which gives end users the ability to build like ad hoc questions and reports on top of that data. So you'll see here that I've got two views, the two that we've literally just been talking about, dim customers and fact orders. And I've got the two views here. We combine them together for one explore, which is kind of definition of a combination of tables. So like talks about the relationships between them, so many to one, and how to join them and what the keys that you join them are, for example. And so if we go to fact orders, if we jump into our orders explore, you'll see that we've got the two tables that you'd expect. And when I click amount, what Looker does is it uses that abstraction to build the SQL query that you want to run. And so when I go and click run now, this will give me the all the order amounts. Oh, that's gone really well. There we go. In the table. And so when you code in LookML, Looker is very good at generating compiler errors. So it's really good at like figuring out when you've put something that is internal to the LookML that will error. So when you build up a measure, which is like an aggregate, you will refer typically to a dimension that you've built in your project. And as I'm typing this, if I put something that is wrong in that LookML, it will automatically flag it. And when you validate your code, it will tell you that there's a bunch of LookML errors, the field amount underscore doesn't exist, go and fix it. And like stops you in most instances from pushing changes that like cause compiler errors on Looker side. And so I will go and save that, I will revalidate, and that will pass. What it's less good at, and what is particularly important when you're dealing with like transformations that are happening before the warehouse, is it's less good at understanding if the SQL that you're telling it to generate is actually legit. So if I put that in, I'm going to validate in Looker, and it's going to tell me, yep, like that's all fine. And so I could conceivably push this according to like what Looker tells you in the IDE, and not realize that I'm pushing something that's going to break for the end user. And so if I come back here and literally just refresh now, we'll see that the SQL has updated and I get an error. And so conceivably, if all you're using is the kind of like Looker IDE validation, you can pretty easily like have an end user get an error like this and like not know it at the point that you're pushing that code. And that's problematic because like fundamentally when you're building these self-service systems, you need the end users to have a lot of confidence in what they're pushing. And if they see these errors a lot when they're trying to query stuff, that's problematic. And it happens a lot. It happens a lot because people make typos or mistakes on the Looker side. And then it also happens because the underlying like tables that they're querying could break. So you can conceivably change something in dbt and have it break in Looker without anyone on that side noticing. And so Josh and I met at a meetup in New York, I guess March this year, and I was on a panel and complained that this was a problem. And I think I said I'd pay someone to go build this if they or I'd pay someone for a service to do it. And Josh, my telling of the story is Josh cornered me at the pub afterwards and said we should go build this thing. And so we've spent the last few months building this tool out. And so the tool that we have built is a tool called Spectacles, because it helps you look better. And Spectacles is we imagine it to be a fully, like a full continuous integration tool for Looker and LookML. And so it will do a number of things, and it currently does a number of things. The thing I'm going to talk about today is really this SQL validation. And so what Spectacles does is it basically goes and generates all the SQL that your Looker instance will generate and tests that it's actually legitimate. It'll test that exactly the error that I've just pushed is actually legit. And so I'm going to jump to my command line. It is a Python package, and so you can just, as some of you, in the same way that some of you would install dbt, you will do the same. And there's a couple different ways. I'm going to jump into our docs. There's a couple different ways that you can tell Spectacles like what your instance is. So by default, we need like your base URL, your client ID, and your client secret. And so you can either pass it via a YAML file, you can either pass it via the command line, or you can export as environment variables, which is what I've done if you have here. So we've got a Looker instance for this. And so what you can initially run is Spectacles connect, and it'll just like authenticate, check that the connection with your Looker instance is good. And then if we go and actually we'll just run against master first. So if we do Spectacles SQL, that'll go and generate the SQL to test it. We pass it a project, which is of course Jaffle Shop, and we will pass it a branch, which will test master first. And so Spectacles will run in 3 possible modes. It'll run in either batch mode, which is the default, which is basically it'll generate a query with every dimension for each explorer and test if that runs. At the other end, there's single dimension mode, which is it will actually generate a SQL query for every individual dimension in your explorer. And so the difference there is like batch will run fewer queries, but you only catch the first error of each explorer, because of like that's what'll come when you run the SQL. And then at single dimension mode, it will obviously build a query for every dimension, but and so you'll catch every error, but like notionally you're putting way more load through your warehouse. And so by default, I'm just going to run this on master. And so if we jump in, it actually isn't going to take that long to run, but if we jump to our queries, we will see what has run. So we've seen that everything passes. And so we've seen that it has built. So this was my error from running it in the Explorer. And now you can see that we've triggered a query from the API that has grabbed every dimension. And you can actually see in here that it has run a like big, ugly query and check that it passes. And it does a couple things here that limit the amount of compute that we put through the warehouse, which is really important. So we do a limit 0, which on things like Postgres, Redshift, and BigQuery basically make it do like a dry run, like an explain query. So it doesn't actually process any data and should, in most instances, return pretty instantaneously. And then the other thing that happens is we put it like where false, where 1 equals 2, because a limit 0 doesn't actually stop Snowflake from processing data, but a where false does. And so that makes it process the queries much more quickly. And so one thing that I probably should have shown is, like, you could do this yourself. You could run that type of test, and this is what like I often used to do. And so it's like the way that you'd go and check that everything was running is you'd go into an Explorer and you'd do this, and you'd grab everything, and this is basically exactly what we've just run. And you would waste a lot of time doing it, and you would then click run. You would catch an error, and then you'd go fix it, and then you'd run it again, and maybe you'd catch another error, and you'd go fix that. And you'd have to do that for every Explorer that view is involved in. So if I'm changing something in like my dim customers view, that's going to be in so many of my Explorers. And I basically have to go and do that everywhere because certain fields will be available in certain places. And that was basically like the very manual and best way to do that. And so what Spectacles does is it basically automates that in like a systematic way across your Explorer, across your Looker instance. And so if we now go here and we've got this error and I'm on branch demo dbt, I can then go back here, and this time I'm going to run against that branch. How did I write that? And I'm going to run in mode single. And I'm actually going to pass the verbose flag so you can actually like see what it's doing in the background. We also, a thing, like we're very wary of how much load you put through your Looker instance one, because there's like compute that's involved there, and then ultimately your warehouse. Spectacles will, by default, kick off 10 queries at a time, or like manage a concurrency of 10 running queries against your Looker instance in your warehouse. But you can actually tell it to do something else. And so here I'm going to tell it 100 because these are pretty small tables and no one else is using this dedicated Looker instance. So if we do that and we jump back here to our queries, you'll see in a second, hopefully, assuming they run for long enough, that a bunch of the queries will kick off. There you go. So they've, a bunch of them have completed, and you'll see that it's basically the same thing, but now there's a larger number of smaller queries, and we would catch all the errors. And in this case, it's still just the one. So we've just got the same error, name amount error, not found inside fact orders. But if I were to go and add another error and run it again, we catch both in a way that we wouldn't get with batch mode. In batch mode, we'd get the first one, and then we'd have to go and fix it, and we'd get the second one, but it would run a far smaller number of queries. And then I talked about the 3 modes. The one in the middle is called hybrid mode. And what that will do is it will run everything in batch mode, catch the errors that fail, and then run them in single dimension. So for Explorers that pass, it just runs 1 query. And then for ones that fail, it like dives deeper into those Explorers and runs every one. We're thinking about implementing, Claire had an idea, and someone else in the community suggested it afterwards, to do like a bisect. And so basically run it at the top level, see if there's an error. If there is, split it in 2, see if there's an error in each of those halves, and keep going down. And basically, depending on how many dimensions you have and what percentage of them are going to have errors, there's like a different break-even point on where you end up on what, like, you could run more. So we're thinking a bit about like ways to optimize that. So you can run this via your command line in the same way that like many people run dbt. Josh and I and other people who are using the tool so far are also using it in CI environments. So I'm gonna, like, say for whatever reason I was making this change and I thought that this column should be called amount error. I'm gonna introduce an error. I'm gonna commit it. And in here we have a, that was it, Circle CI file. So you can see that we're just like installing Spectacles, we're testing the connection, and then we're running it in batch mode. And so when I open my pull request, introducing the error, this will go off and run. And so this will do, I guess, I hope, what we all expect it to do, which is to show an error that we introduced as part of that. We can probably see it if it's not already done. There you go. So you see exactly what we'd expect. Amount error not found inside fact orders. You can then, you'll catch it here in the way that you'd expect, and you will then go and fix it. And so I would go and fix that. Commit it, that'll end up on my pull request, and it'll go off and run it. And so while that's running, I'll talk about, like, we obviously think you should have this on your, in like Git where you're having code reviews, and not in the Looker IDE lets you run some tests, and it lets you run like some of these things. It's a slightly frustrating workflow as someone who's reviewing the code, because you basically have to jump into your IDE, you have to check out the branch, and you have to like make sure everything validates. And so what's nice about this is like I probably don't need to explain this to all of you, but it's nice that it like shows up on GitHub and you can actually see exactly what's happening, and you don't need to like jump somewhere else. Cool, so that's passed. The other thing is obviously we want it to like do these things in a much broader way. So we believe that there's a large number of tests that you probably want to, like, LookML is code and you should test it as such. And there's a large number of things that you could do to validate that, and that includes linting and other things. And so this is the first step. We imagine like testing primary keys and things like that in your views will be like one of the next steps. Something to flag or talk about, I guess, when we talk about deploying this in a CI environment is, and it's worth like digging into exactly what it's doing in the back end. What Spectacles does is you pass it users. So I, in my CI environment, I created a dedicated user to run Spectacles. And what Spectacles does when it runs is it uses the Looker API to move that user to its dev workspace, like its dev environment, which is basically what happens when you have this purple bar up here, which is like you're making changes. And it then checks out the branch that user is on. And so, then it runs all those queries on that branch. And so when your first job kicks off, that like works really well. And then you have a second analyst who kicks off a job. Let's say your job runs longer than like the 12 seconds that one takes. Someone else kicks off another job. And if your CI environment is using the same user, it will move that user to the branch of the second pull request, which means that now both jobs are running against the same, like the second branch. And so your first job is effectively broken, is no longer testing the right thing as a result of like having those concurrent runs. And so there's a couple ways you can solve that. Like handling state and stopping that concurrency is basically the main one. Or like having a pool of users that you can use, but like having a service that manages that pool of users. A lot of the CI tools don't make that super effective. And so what we're launching in the new year is a managed solution for Spectacles. So it's an easy way to like deploy this, get those notifications on your GitHub pull request, and ultimately like manage that, either a pool of users if you want it, or like if you only want one user, managing the concurrency and like stopping those runs from breaking each other, and ultimately just like providing a nice UI for people to be able to see the output of these things. Part of it is that we think kind of like we want to make it really accessible to the power users of Looker. And I think a lot of those people may not be familiar with Circle CI some of the time, or Docker, or all those things. And so making that as easy as possible for those end users is something that like we're thinking about a lot. And so that would be done, and this presumably, refresh. Yeah, there's now no changes because I've introduced a change and revert that change. And so we obviously wouldn't merge this in, but that's kind of the flow that we see happening with Spectacles. If you're keen to use it, check out the docs. Like, we'd love for people to install it. We have a Slack channel that we're using to help, a Slack community that we're using to help people deploy it and kind of getting feedback from the early users. So if you sign up for the updates, we'll invite you to our Slack community, and we'd like love to talk through how we can extend this, how we can keep developing it, and just like helping people use the tool. We've been, I think Josh and I were a bit sobered by, I'll speak for myself. I was definitely sobered by the number of errors that I found when I first deployed this tool on some of the Looker instances that I use. And in part, that's like people making typos in LookML or making errors in LookML. And in part, it's making changes to dbt and not being fully conscious of what is happening on the LookML side. And so we imagine this as a tool that doesn't necessarily just run on LookML repos. It would also run on repos that LookML relies on effectively. So you could run this on your dbt repo. You obviously need to have that work in a way where it like runs all your Looker SQL on top of the testing data that you've built as part of that dbt PR. And so there's further work to be done to really make that work seamlessly. But we imagine fully seeing this like not just get run against LookML repos, but again, run against repos all the way along the data stack as changes are being introduced to make sure that you're not introducing errors for the end users. So yeah, we'd love to have people try it out. Sign up for the updates, come chat with us. We're in the dbt Slack all the time. So yeah, happy to take any questions if people have any. Cool. Yeah, reach out, get in touch if you want to ask anything directly.
Cool. My interim solution will still be a pull request checkbox, which is like, have you changed anything in prod? Where's the looker PR? So adds a bit more structure to that. But I recommend everyone add the pull request checklist. That's a first stop as well. Yeah, thanks so much for sharing that. Very exciting stuff. So my last thing on testing, I'm going to rush through this because I want to leave a little bit of time for questions at the end, even though it won't be too much. I don't have a meeting after this. I've just got a Christmas party. So no, I don't want to do that. That's just our internal slide. Okay. We cut a new release of utils yesterday. It's a patch release. That's the major minor patch. But we built some new tests and just wanted to share those because I think they're pretty cool. This is technically JAFFLeshop, but I just changed all the data in it. So, it's not really JAFFLeshop anymore. One of the tests that we added was a test for periods or ranges that shouldn't overlap. I found this a lot when I've been working with subscription data that has a start and end date, or even I can imagine like if you had bucket like categories of ages or like some numeric variable that should have a lower bound and an upper bound where those ranges shouldn't overlap. And the reason that it can be problematic is if you're doing a join on an inequality join to like fan things out and you get duplicate records, and it's kind of hard to work with that. So especially if you're using snapshots, this becomes, well, no, snapshots work as expected. But anyway, so you can imagine some subscriptions data with a subscription ID 1 and 2 and different valid to and from dates. So we built this mutually exclusive ranges to say that between my valid from and my valid from and valid to, but also to the future. For each subscription, these ranges should never overlap each other. There's an extra parameter for whether like you're allowed to have gaps between these ranges. So allowed, required, and not allowed, I think the versions are. Yeah, that's right. And so when you run this test, it does some pretty cool window functions to check this assumption. I found this really useful in testing some of my source data, just checking my assumptions there. And then the other one that we get questions about a lot, and I've had this test on my computer for like sitting on a project for a long time, is unique combination of columns. So I don't have one record per product, I have one record per product per month. And the advice that we gave for a really long time is to construct a unique ID and test the uniqueness of that ID, or to instead like pass a concatenation of those fields to the uniqueness test. When you're testing source data, which I've been doing more and more recently, is pushing my tests as far upstream as possible to the source data. You can't really construct a unique ID. You can't use SQL to do that. But you could pass it a concatenation of two fields. But then there was a thread the other day which just showed like that's like such a more expensive query than just passing it, group by month and product. So like select month, product, count star, group by month and product. So I ended up open sourcing this test. So these all, so that's the things there. JAFFLs make, they get in there. So when I run these tests, as expected, everything passes. Check them out on utils. Yeah, I had to check if that was the thing. Really bad at leaving open good tabs. We had our release. We did a release yesterday, as I said. That was some new functionality we built. We also had a huge number of contributors, possibly because we'd got a while between releases, so how bad. But yeah, some other good stuff in there as well. A cool query to make working with like statements and the run query macro even easier. You don't have to look at the Agate documentation anymore if you use this query, which is a big relief for me. And a macro that Klaus wrote, which takes some Snowflake functionality and ports it over to Redshift and BigQuery as well. Yeah, that's all I wanted to share on office hours. We have 7 minutes left. I did indeed run through that very quickly. So does anyone have any questions on anything we talked about today? Any comments, anything they're working on they wanted to share?
A real quick question about the mutually exclusive ranges test. Do you have an option for specifying whether the end date is inclusive or exclusive?
Yeah, so that's the gaps, like the gaps parameter.
Oh, okay.
So essentially, that's what it boils down to, is like inclusive and exclusive. But it's kind of was like this almost like, is it mutually exclusive? Sorry, is it actively exhaustive? Is it inclusive, or is it exclusive? There was kind of 3 options. So we went with gaps because we felt that was kind of easier to understand. So there's some notes on the utils docs with a few examples. So if you have like 1 to 2 and 3 to 4, that might pass your test. Like you might be like, yes, that's totally valid for this data set. But there's other instances where you'd want like 1 to 2 and 2 to 4. Or you can imagine for date ranges, sometimes you actually want the day before, so they don't overlap.
Right.
Things like that. So yeah, that's a parameter that you can add on there.
Is there an easy way to subscribe to utils releases, like an RSS feed or a channel?
Yeah, you can. That's a really good question. You can watch the package on GitHub. That's not a super good answer. What I would love to do is build like a little bot to like just put into a package releases channel. We have every piece of the puzzle to do that. We just haven't done it. So yeah, basically like every time we do a package release, it pings like our hub website so that we can update like the hub website, and we can just use the webhook from that. Like when that pull request gets merged, there's a deploy webhook that we can send out and like hook it straight into Slack via Zapier or something like that. Yeah, it's not great at the moment. That it's like, hey, we can't do release, or I just don't say anything. That's the other option.
We all need that magical free time.
Yeah. I actually just need the right privileges on the repo, if I'm honest. I'm not an owner on that one, so I can't set it up. But these things happen. Cool. Any other questions? If anyone's looking for a super fun query to take on, I was just thinking about this when Dylan was presenting. I would love someone to write the query that tells me what column names have changed between my prod and dev instances on my dbt runs. Like when I open a pull request, if I could just have the query that's like, by the way, did you know like these columns existed in dev and they will exist in prod and they no longer exist in dev? These are the things that go through my mind. Anyway, okay, cool. We'll close it up there then. I'll stick around for another minute or so if anyone has any late game questions. But other than that, I don't think this is probably it for the year. We'll see you in the new year. Happy Christmas, happy Hanukkah. Enjoy the holiday season. Oh, see ya. See you soon, Emily.